Hello everyone. I want to show you that we can use our quotient rule and product rule that we talked about in our actual lessons. And I'll post the link to those if you want to go back to that and see how we did it. But I wanted to show you that using our difference quotient of our definition of a derivative, that this will be true for all cases. So let's say, for example, that we have some function, capital F of x equals f of x times g of x. So in this case, this is a multiplication of two functions, f of x and g of x. So this would mean that this would be using our product rule. So first thing I'm going to do, if I want to find my derivative of f prime of x using my basic definition of a derivative, I'm going to set this up as the limit as h goes to 0, f of x plus h minus f of x all divided by h. Now, we know what f of x is. It's f of x lowercase and times g of x. So we need to figure out what is f of x plus h. In this case, I would plug in x plus h anywhere I have an x in our function. So this is going to be the function f of x plus h times the function g of x plus h. So now plugging this in, this makes our limit, the limit as h goes to 0, f of x plus h times g of x plus h minus f of x times g of x all divided by h. So for the next step, what I'm actually going to do is I'm going to use a trick where I'm going to add and subtract in the same value, right? So if I added in anything, let's say I added in 2x and I subtract 2x, those would cancel out, meaning I haven't actually changed the value of whatever it is that I have here. So this is going to be equal to the limit as h goes to 0. And I'm also going to rearrange things. I'm going to put it in a specific order, and you'll see why in a minute. So we have our first term here, f of x plus h times g of x plus h. And then now I'm going to bring in my first other term, which is going to be minus f of x plus h times g of x. But of course, if I added it in, I also have to subtract it. That way it equals out to 0. So I haven't actually changed what we have here. So this is going to then be plus f of x plus h times g of x. And then, of course, I will just continue on putting my minus f of x, g of x, and then this whole thing is still divided by h. Okay, so you might now wonder, why did I do this? Well, it's actually because if I look at these two terms, I have f of x plus h and f of x plus h. If I look at these two terms, I have g of x and I have g of x. So what I'm going to do is I'm going to pull those out, and this is going to become the limit as h goes to 0, pull out the f of x plus h, times g of x plus h minus g of x. Same thing here. I'm going to pull the g of x out. So this is going to be plus g of x times f of x plus h minus f of x. And this entire thing is still divided by, looks like my marker is dying, so I'm going to switch over to purple. So this whole thing is still divided by h. Now, you may see what I'm starting to do here, because now what we're going to do is remember our limit laws. If I have the limit of something times something else, that means I can take the limit of the first thing times the limit of the second thing. So this is then going to become the limit as h goes to 0, f of x plus h, times the limit as, don't know why I put that line there, limit as h goes to 0, g of x plus h minus g of x divided by h plus, right? Because think about it this way. If I have A times B over C, I could write this as A over C times B. That's all I did. I just put the H on this term, but it's still, because these two are multiplied, doesn't change anything. Plus the limit as H approaches 0, g of x, times the limit as H approaches 0, f of x plus H minus f of x divided by H. Now looking at this, first of all, if I evaluate this limit here, the limit as H goes to 0, f of x plus H, this means that this H term is going to go to 0, and I'm going to be left with f of x times. Now look at this term right here. Limit as H goes to 0, g of x plus H minus g of x divided by H. This is just our difference quotient giving our definition of a derivative. So this is going to be equal to the derivative of g of x, so g prime x, plus the limit as H goes to 0, g of x, there's no H in it, so this is just g of x, times, again, limit as H goes to 0, f of x plus H minus f of x divided by H. This is just our definition of a limit. So this is going to be, this is just our definition of a derivative. So this is going to be f prime of x. So then rewriting this the way that we were using in the lesson, this is just going to be f g prime plus g f prime, which is our product rule. Now, of course, when I was doing it, I actually wrote it by flipping the two terms, which would be g f prime plus f g prime, and that was just to keep it kind of in the same order that we have when we do our quotient rule. So right there, I've shown though that if I have some function, in this case capital F of x equal to some function f of x times some function g of x, I've actually shown by using our definition of a derivative that this is equal to our product rule, meaning that anytime you have a function in terms of two functions multiplied by each other, this rule will always be true. So now we're going to do our quotient rule. So we have the function, again, capital F of x, and this is going to be equal to lowercase f of x divided by lowercase g of x. And using our definition of a derivative, we're going to have the limit as H goes to 0, f of x plus H minus f of x divided by H. So in this case, f of x is just equal to f of x divided by g of x. F of x plus H, I don't want to keep doing this, capital F. This is going to be equal to f of x plus H divided by g of x plus H. So now let's figure out what our derivative is. So our derivative, f prime of x, is going to be equal to the limit as H goes to 0, f of x plus H, which we just said is f of x plus H, divided by g of x plus H, minus f of x, which is f of x divided by g of x. And then this entire thing is divided by H. So the first thing I'm going to do is I'm actually going to get both of these in terms of a like base so I can actually work with them. And I'm also going to pull this H up to here, right? Because if you think of this H as H over 1, this means that if I were to do fractional division, this 1 is going to come up to the top. This H is just going to come to this term. So to get a like base, or the same denominator, I need to multiply this one by g of x over g of x. And I need to multiply this one by g of x plus h over g of x plus h. So in this case, this is going to end up being f of x plus h times g of x. I'm actually just going to combine it all together because I'm going to end up putting it together anyway, right? They're going to have the same base, g of x plus h times g of x. This one's going to be g of x times g of x plus h, same thing. So this one is going to be minus f of x, g of x plus h. And then this entire thing is going to be divided by g of x plus h, g of x, and then of course times h. Okay, so now I'm going to use a trick just like I did before. What I'm going to do is I'm going to add and subtract out a term, which will then allow us to rearrange it into the form that we want. So we're going to have the limit as h goes to 0. And then first thing we're going to have is we have our f of x plus h times g of x. And we're going to subtract f of x times g of x, and then plus f of x, g of x, which of course, as I said before, because these two are the same term, plus this minus this, they cancel each other out to 0, so I haven't actually changed what we have on in our limit. And then minus f of x, g of x plus h, and then of course this entire thing is still divided by g of x plus h, g of x times h. Okay, so as before, we're going to see what these have in common. Well, these two both have a g of x. These two both have an f of x. So let's do what we did before. Let's pull those out. So this is going to become the limit as h goes to 0. I'm going to pull g of x out. So g of x times f of x plus h minus f of x. I'll just put this in parentheses so we know it's this g of x is multiplied by both of these. Okay, so next thing, now I'm pulling out f of x. So this is going to be minus, so I pulled out minus f of x. So minus f of x times, so if I pull out minus f of x, this is going to become positive. So this is going to be gx plus h minus g of x. Right, because all that happened is this became negative, this one became positive, and I just put the positive term first. And the whole thing is still divided by g of x plus h, g of x times h. Now I'm going to split it like I did before. So this is going to be equal to the limit as h goes to 0, g of x times the limit as h goes to 0, f of x plus h minus f of x divided by h minus the limit as h goes to 0, f of x times the limit as h goes to 0, g of x plus h minus g of x divided by h, and then this entire thing is divided by the limit as h goes to 0, g of x plus h times the limit as h goes to 0, g of x. So limit as h goes to 0, g of x. Well, g of x has no h in it, so this doesn't get touched. So g of x. The limit as of f of x plus h minus f of x divided by h. This is just going to be your derivative of f of x. So we're going to write this as f prime of x minus derivative of f of x, or sorry, limit of f of x as h goes to 0. There's no h in it, so this is just going to be f of x times limit of g of x plus h minus g of x over h. Again, just the definition of a limit. This is going to be g prime of x. And then finally, divided by the limit as h goes to 0, g of x plus h. That's going to make this h go to 0. So this is just going to be g of x times the limit as h goes to 0, g of x, which is just g of x. So this would be g of x times g of x, or g of x squared. So if you look at this, this is just our quotient rule, right? Our quotient rule was gf prime minus fg prime divided by g squared. That's exactly what we have here. G of x times f prime of x minus f of x times g prime of x divided by g to the gx squared. So this is just to kind of show you that when we use our definition of a derivative, this is always true. We talked about this. So these rules, though, are also always true. And I've shown you that no matter what my function f of x and g of x are, these will be true, both the product and the quotient rule, as long as g of x is not equal to 0, which would be the case even if we weren't doing the quotient rule, right? Because if we got to this point where we had g of x equals 0, it would be dividing by 0, and this would cause the whole thing to not work. So this restriction would be true whether you're using the definition of a derivative or whether you're using the product or quotient rule. Thank you for watching. To continue learning, click the linked video here for the next lesson. If there's a topic you'd like me to cover, let me know in the comments. Don't forget to subscribe, and I'll see you in the next video.